point P. And this is, what we mean by the coordinates of P in polar system. Okay, and that's what I explained here. Is it okay? So next we'll see how to locate such point. All right, so let's suppose here we have the point P with coordinate r and theta. As I mentioned before, the first, here value r represent the length of the segment OP, and theta, the second entry, represent, the angle between the horizontal line and the segment OP. And the positive direction is from the horizontal line to the segment to locate this point. Now, to locate this point here, for example, this point, which is the symmetry of P, is the symmetry with respect to O. What we mean by symmetry is the distance between OP is exactly equal to this distance between O and Q. That is meant by the symmetry with respect to O. So it means they are symmetric with each other. Now, how to find the coordinate of this symmetry? So since they have the same distance r and different angle, so this angle here for Q is obtained from this point, the right angle up to here. If you start here and go up to here, you will get your angle. And how to calculate it? Knowing this blue angle, which is equal to theta, you guys have to add 180 degrees. And 180 degrees in radians is equal to pi. So that's why the right angle here is equal to theta. So the right angle is equal to theta, and from here you add pi. And now the coordinate of this symmetry is equal to r theta plus pi. But there is another way or different other ways to represent the coordinates. One of them is knowing this point is the symmetry of P with respect to O. Instead of using a big angle like theta plus pi, I'm going to use this angle theta, but I'm going to use almost the same coordinates r and theta. But if I use r and theta, I'll get this point. I'm going to add a negative sign to r in order to say the minus sign means I'm going to take the symmetry. And that's exactly what I did here. And it's the same point. So you see this point, these coordinates are similar to the coordinate of P, except this negative sign. And the meaning of this negative sign is we're taking the symmetry of P with respect to O. If you don't take the symmetry, you have to add theta to pi in order to get the same point. So you guys can see you have two ways to represent the coordinates of the 2 points. Any question? If, for example, you guys want to look at the point, I'm just going to give you another example now with the values of r and theta. So let's suppose you guys want to, let's see, you want to get this point. I'm going to call it S, and the coordinate of S is going to, so let's suppose here in polar S is, for example, let's say 3 and pi over 2. Okay, I'm gonna represent 2 points. And let's say we have T with coordinate -3 and pi over 2. Okay. So if I want to locate the point S, first step, you guys have to find pi over 2. Where is it? Okay. And to find pi over 2 radians is equal to 90 degrees. It means you have to find an angle equal to 90 degrees, right angle from this line. And a right angle gonna be, for example, here from O, guys will get here. And this angle here is pi over 2. So knowing now the angle, you have to use the radius R. So if R is positive, you stay in this same quadrant. You take 3 units from 0. So we have here 1 unit, for example, 2 units, and 3 units. So this point here, this is when theta equal to pi over 2 in radians, or 90 degrees. And the point here is my S. And you guys see you have here 2 and 3. Now, if I want to locate the point minus 3 pi over 2, you guys can see here, it is similar to this point, except we have a negative sign. It means you start, as I told you, finding what is pi over 2 first. Pi over 2 is the same that we have here. Knowing the value of pi over 2, you check R. If R is positive, you stay here in this quadrant. Now R is not positive, it's a negative. It means you have to change the quadrant by taking 3 units below O here, because it's the opposite or the symmetric of this point. So it's going to be this point here below. You take 1 unit, 2 units, and 3 units here. And this is going to be your T. This point is T. Okay? Now, if I want to get the point, let's say, I'm going to call it K with coordinates, let's say 2 and minus pi over 4. So since the angle is negative, you have to take the opposite direction. I told you at the beginning, this is the positive direction. Okay, this way is a positive direction, and this is a negative direction here for the angle. Pi over 4 is equal to 45 degrees minus pi over going to be negative 45 degrees. It means you have to go this way, and all this angle is equal, is a right angle, is going to be just 90 degrees. You take half of this angle, is going to be exactly this, half of this angle. And this angle is equal to minus pi over 4. Because it's a negative, we take the negative direction. And finding, just given it, as I told you, you want to locate the point K. You always start by finding the angle, and as soon as you get it, you check the sign of R. If R is positive, you stay in the quadrant where the angle is. If the R is negative, you go to the opposite quadrant. So here, if R is positive, I'm going to stay here. If R is negative, I have to take the opposite quadrant, which is the second one. So since my R equal to 2, I have to take is positive. I'm going to stay here by taking 2 units from 0, the pole. I have here 1 unit, for example, and 2 units. I'm going to get here my point K. Okay, so this is how to locate a point knowing its coordinates in polar system. You always start by finding the angle, as I said. If you notice, the value of R is positive, you stay in the quadrant where the angle is. If R is negative, you take the opposite quadrant. And opposite quadrant respect to O. Opposite quadrant of the opposite quadrant to the first quadrant is this one. They are opposite each other with respect to O. And these two, the second and the fourth one, are symmetric with respect to O. Okay? All right. Now let's move on. If there is no question, how to locate a point. Sounds good? All right. So next we'll see how to go from this one system of coordinates to another one. We here consider the two cases. In the first case, we suppose the function is the point is in Cartesian coordinates. We want to get the coordinate in polar system. And as I mentioned here, you have to use these two formulas in order to go from Cartesian coordinate system to polar system. And these two formulas are obtained just from what I did before. You guys can see it here. Let's say your point is already here in terms of X and Y. This is your point P. It means in terms of X, this is going to be the value of X. And this is the value of Y. Okay? And in polar, so we suppose X and Y are known, and we want to get R and theta. And when you guys want to get R and theta, this is going to be your R. As we did before, R is the length of the segment joining O and P, and this value is R. And for theta, is going to be the angle joining the horizontal line and the segment OP. Is going to be this angle by taking the positive direction. This is your angle theta. And from this picture, you guys can see, if you want to calculate R because this is going to be just a right triangle, because this is the right angle here. So you see, when you want to get, R, because X and Y are known. So if you want to get R, you use Pythagorean theorems, and the Pythagorean theorem says the R is equal to this side, which is equal to X, you square it, plus the opposite side, which is equal to Y, you square it. And you will get exactly this formula. It's just obtained from Pythagorean theorems. Okay? And now when you want to get the angle theta, you guys can see from here again, tan of theta is equal to opposite side from the right triangle, opposite side over the adjacent side, but opposite side is equal to Y, and the adjacent side is equal to X, and you will exactly get this formula. So we'll see later how to use them. Okay? For the second formula, it's only used when you guys want to go from the polar system to Cartesian system. It means, in this case, R and theta are known, and we want to get X and Y. If R and theta are known, you guys can see from this graph again, if you calculate cosine of theta, for example, and cosine of theta from a right triangle is equal to adjacent side, and the adjacent side is just X. This side is going to be X over the hypotenuse, and the hypotenuse is equal to R. And from this equation, you guys can get this, the first formula. So it means X is equal to R times cosine of theta, right? For the second formula is drawn from calculating the sine of theta by using the right triangle. So sine of theta from the right triangle is equal to opposite side, which is equal to Y over the hypotenuse. And from here, again, you guys can get the second formula. And as I mentioned before, these two formulas are used to transform a polar coordinate into a Cartesian coordinate. Any question? Any question? All right. Let's move on. So next we'll see an example. Calculate here, for example, the first one. So here we have the two coordinates in polar, in Cartesian system, and we want to get them in polar. So it means we want to get r and theta. So from here, if you guys want to get r, so we know r squared is equal to x u squared is going to be 1. You square it plus √3 u squared. That's exactly what the formula says. You square x and y. And you will get here 4. If you get 4, so it means we have two possibilities for r. We can get r equal to plus or -2. Okay, so we'll pick one of them and just, and before choosing any of these two values, we can calculate theta first. Tan of theta, as the formula says, it's y going to be √3, because √3 is y over x, and x is equal to 1. And so here you guys can get two possibilities. It means so which angle has its tan equal to √3? Pi over 3. Okay, pi over 3, so we can get theta equal to pi over 3. And what else? Pardon? Yeah, theta equal to what? Yeah, 60 is pi over, this is 60. This is 60 is a pi over 3. It's in radians. As it is at the beginning of the class, you have to provide your angle in radians, not in degrees. It's going to be 60 degrees, which is equal to pi over 3. And which angle again? So this is in the first quadrant. And in the second quadrant, is there any angle for which the tan equal to √3? Second quadrant. So means between pi by 2 and pi. Now, the next angle is in the third quadrant.
$120.
Yeah, in radians, I said it's going to be 4 pi over 3. So how to get it? You just add pi. Okay. So if this is, this is pi over 3. This angle is pi over 3. It's 60 degrees. And the next angle for which the tan equal to the same value √3 is obtained from the continuation of this line here. And if you want to get this angle here, if you want to get all this angle, so you have to take the green one and you add pi. I'm just going to change the color here again. You guys can see here the blue one is equal to only pi, which is equal to 180 degrees. So if you take this one, the green one plus the blue one, you will get the red angle. So that's why I said, to get this one, how to get it? 4 pi over 3 is obtained from pi over 3, you add pi. So you can say here, pi over 3 plus pi, and you will get the other solution. So you guys can see the blue angle, the green angle here, which is called pi over 3, plus the blue one gonna give you the red angle. And that's what we got here. It's for the red angle is the second value here. So it means you have two values for theta and two values, because your theta should be between 0 and 2 pi. Because if you go beyond, you repeat the same point indefinitely. So you see here, okay, you have two values for 2 and two values for theta. Now, which value of r matches with the value of theta? So can we take 2 and 4 pi over 3? If you take 2 and 4 pi over 3, your point is gonna be here in the third quadrant, and your point should be in the first quadrant based on the values that you guys have here. The x value is positive, you can see it, x value, and the y value is also positive. It means this point should be in the first quadrant. Okay, you guys can see here you have several possibilities. You have 2 and pi over 3. I'm gonna list all of them and we'll see which one we have to pick. This is one of the solution by taking here 2 and pi over 3. I can also take all right, I can take it 2. This is one of the solution. The other one is I can take 2 and 4 pi over 3. I just want to check all combination here. And I can also take, -2 and pi over 3. And -2 and 4 pi over 3. Okay, so we have 4 possibilities. That's from these two solutions. Okay, we have 2 values for r, 2 and -2, and 2 values for theta. So it means the solution, the value of p gonna be one of these, or from these solutions. Now you guys can go, one by one. What do you think about the first value here, the first one? Could be p. Yeah, it could be p, because you guys can see, as I told you, pi by 3, you start by locating pi by 3. So pi by 3 is in the first quadrant, and you take 2 units, because in the first quadrant, and r is positive, it means your point is gonna be here. in the first quadrant. You have 1 unit and 2 units. So it means this works. Why? Because my point here is should be in the first quadrant because X and Y are positive. And what about the second case? Exactly. You guys can see here 4 pi over 3 is here in the third quadrant. And in the third quadrant, I told you the point should be here if R is positive. If R negative, gonna be here. But you see, this value is in the third quadrant and P is positive. It means this point is in the third quadrant. We cannot take it. We cannot take this because this point is in the third quadrant. That's why we cannot take it because our point is in the first quadrant. Even if these values satisfies, the equation here. So what about the next value? -2 and pi by 3. So where is this one? This point? No, we cannot take it, right? So you're right, your first question answer is correct because this point is in the third quadrant. Because if you take pi by 3, you are here in the first quadrant, but since the R is negative, the negative sign I'm gonna send it to the third quadrant. So that's why we cannot take this one. This point is also in the third quadrant. So what about the last one? Can we take it?
Yes, sir. It is in third quadrant.
So this one is in the first, second, or third quadrant?
Third quadrant.
First quadrant.
No. If it's in third quadrant, it means we cannot take it, right? Because that does match with our point. This point is not in the third quadrant because, you guys can see the angle is in the third quadrant. You're right. But so since the value of R is negative, this send the point to the first one. So this one is correct. Because this point here, without the negative sign, the point gonna be somewhere here. This point is 2. This point is 2, 4 pi over 3. Now, if you add the negative sign, because I told you when you guys find the angle, now you check the sign of R. If R is positive, you stay in the quadrant where the angle is. Now, you see here, you found the angle, it's in the third quadrant, and the sign of R is not positive. It means we cannot stay in the third quadrant. We have to take the opposite quadrant with respect to O is going to be this first one. And exactly what we have for P. So anytime you guys have this kind of problem, you will get 4 possibilities and you check which one gonna work with your point. Is it okay? Yeah. Yeah, so this point here, these 2 points are the same. It's the same point P. And they in polar, they are this point here in Cartesian. This is exactly the same point. So here we have it in Cartesian coordinates, and in polar we have two ways to represent the same point. So that's, basically the difference between the two systems of coordinates, because here in Cartesian coordinates, we have only one way, a unique way to represent the coordinates. But for polar, we have different ways to represent the point. Okay? As I told you at the beginning of the class, to locate this point, you take pi by 3 first. If pi by 3 is in the first quadrant, you check if R is positive, you stay there. If R is negative, you take the opposite. The R is positive, you stay there, and it coincides with exactly our point. Okay? And for this last one, 4 pi over 3 is in the third quadrant. If R is positive, you stay there, but R is negative, you're gonna send it here. And you will get this point. Yeah. Okay. Yeah, now I'm gonna do the second example. So that's exactly what I represent here. If you guys want to take the notes. Okay, so we got plus or negative 2, and we got pi over 3, gonna be just this the sum. If you add pi, you get the second point. Not the second point, but the other way to represent the same point. Any question? Yeah. Yeah, the same point. So I just did in order to show you have different ways, to represent the same point. But it's gonna be helpful, when comes time to sketch the curve. You need to understand what the meaning of the negative R. It means the symmetry. That's why I said when you want to locate this point, for example, in order to sketch a curve, you first locate the angle. And when you get the angle, if R is positive, you stay in the same quadrant in order to find your point. So for example, this point, if R was positive, it was 2, the point gonna be here. But since R is negative, you have to take the symmetry gonna be this point. With the negative sign of R, you get this point. Because this angle is in the first quadrant, in the third quadrant, and the negative sign, I'm gonna send this point right here. Okay. All right, so let's see now the second example.
So can you repeat the first one?
Repeat what?
Why is R minus 2 and we are giving the line in the first quadrant?
The point that we wanna get is already in the first quadrant. That's why my point should be, even if I use polar system, my point should be in the first quadrant because I have two values, positive values. Here's this point you guys can see is in the first quadrant. X is equal to 1, y equal to √3. My point is here, first quadrant. So that's why I said, my theta should be in the first quadrant. And theta is the first quadrant, means that theta should be between 0 and pi by 2. Now you check the trigonometric table, which angle has its tan equal to √3. We have only one angle in the first quadrant, for which the angle the tan equal to √3, it's pi over 3. And I said, since our theta is equal to pi over 3 in this first quadrant, and my point is already there, my r, if I want to stay in the first quadrant, my r should be positive. That's why I choose here r equal to 2 and get this point. The other possibility is the other angle for which tan equal to √3 is 4 pi over 3. The tan of 4 pi over 3 is equal to 3. It means this theta, value of theta, is also satisfied, this condition. It's also one possible solution. It means, and this angle is in the third quadrant. But I know my point cannot be here. If I take my pi over 3, my point is going to be in the third quadrant, and it should be in the first. That's why in this case, I don't have to take a positive r. I have to take a negative r in order to send it to the other quadrant, because I told you this is going to be, the negative sign means the symmetry. So that's why I multiply this by minus by taking the negative value of r in order to send this point right here. Is it okay?
Yes, sir.
All right, thank you. Let's see another example. So we take this point is -2, -2. In Cartesian system, we want to get the polar coordinates. We're going to start by calculating r. It is an x u squared. This is my x and this is y. After calculations, we will get 8. And if r squared equal to 8, so r going to be plus or negative √8, which is equal to plus or negative 2 √2. Okay, I'm going to calculate tan of theta. So tan of theta equal to y is over x. So y is -2, x is -2, so it means we'll get 1. So which angle has its tan equal to 1?
5
Yeah.
by 4 and 5 by 4 and 5 pi by 4.
Yeah, you have pi by 4 and 5 pi by 4.
5 by
Right. But since I know my point is, you can pick both. Okay. But since my point is in the third quadrant, because these two values are negative, so it means my point is here in the third quadrant, -2, -2. So it means if I take pi by 4, as you said, my point gonna be here because this is pi by 4. If I take pi by 4 as the angle, so my r, if my r is positive, I'm gonna be here. That's why for pi by 4, I have to take a negative angle, and the negative angle is obtained from this negative value here, and we will get this point. Instead of taking pi by 4, you also gave me the second solution is 5 pi by 4. And 5 pi by 4 is already in the third quadrant. So it means since we already here, we have to stay here because the point is supposed to be there. That's why we have to take, in this case, a positive r in order to stay here. When 5 pi by 3 already send it to the right quadrant. By taking 5 pi by 4, we already send it to the right quadrant. We only have to take a positive r in order to stay here. And as I said, for the first possibility, if you take pi by 4, you're gonna be in the first quadrant. And since the solution, the point is in the third quadrant, we have to send it here by using the symmetry. And the symmetry means you have to take a negative value for r in order to send it here. And we have only two possibilities. The negative value is -2 √2. Is it okay?
Sir, why the polar coordinate is not -2√2, 5 pi by 4?
Pardon?
The polar coordinate is not -2√2, 5 pi by 4.
-2√2 and
5 pi by 4.
no, because if you take 5 pi by 4, the point is already here. Now, if you take a negative r, the negative are gonna send it here, and you will get a point in the first quadrant, and the point is supposed to be in the third one, because you guys can see you have -2, -2. It means that this is right position of the point. If you take 5 pi by 4, you already here, and by taking -2, you will be here. -2 root 2 gonna be here with this angle. That's why we cannot take it. You getting me?
Yes, sir.
Right. All right, next example, we'll do the reverse way. Now the point is in polar, so you want to get it in Cartesian system. So in this case, you guys have to use these two formulas that I already mentioned. So you have to use these two formulas in order to find the coordinates in Cartesian system. Okay, that's exactly what I did here. So I use the first formula, x is equal to r cosine of theta. Now I'm gonna substitute r and theta by their values. So r equal to 2 and theta equal to 2 pi over 3. That's exactly what I did here. So we'll get 2 times cosine of 2 pi over 3. And you guys know cosine of 2 pi over 3 is equal to -½ And after calculation, you get x equal to -1. And for y is going to be r sine of theta based on our formula. And we'll get here 2 sine of theta. So I just substitute theta by its value. So here theta equal to 2 pi theta equal to 2 pi over 3. Okay, so when we calculate sine of 2 pi over 3, so we'll get √3 over 2. And when we simplify by 2, going to be just √3. So it means x is equal to -1 and y is equal to square root of 3. Any question? Is it okay? All right, for the second, yeah.
No,
All good, sir.
I didn't get you.
All good, sir.
All right, thank you. Let's see now the second example. Now we have a p with coordinate equal to 2 and -pi over 4. And then x equal to, again, we're going to use the same formula. X is equal to r cosine of theta. And here I just substitute r by its value, which is equal to 2. And theta is equal to -pi over 4. And when we calculate the cosine of -pi over 4, we'll get just we'll get √2 over 2. And then when we simplify here, you guys see you will get just √3 as the value of x. and applying the same formula that we did, in the first example here to get y. So we'll get just, you substitute r equal to 2 in our case here is the first entry, and theta is equal to -pi/4. I'm just applying this second formula right here to get y. And sine of -pi/4 we know is equal to -√2/2. So basically it means here the coordinates of P in Cartesian system going to be √2, -√2. Any question? Sounds good? All right. So we're done with these two examples. So now we're ready to define, a polar curve. And later on, we'll see how to sketch it. So polar curve is, similar when you guys define just, a curve in XY axis. Okay. So you guys know when you have X and Y axis, and when you define the curve of a function, it's going to be just, Y equal to f of X. Okay. So we just use similar notation, but instead of Y and X, here is going to be R and theta. Okay. So we will get here R as a function of theta, or we can also get sometimes theta as a function of R. So for example, in XY coordinate, it's also possible to get X equal to G of or H of Y, for example. In this case, the function is going to be in terms of Y. Okay. So both, possibilities are, exist. So exactly the same thing what you guys have in polar coordinates. In polar coordinates, theta sometimes is going to be the independent variable, and are going to be the dependent variable, or vice versa. But in 1700, most of the time, so we'll use we're going to use present our function or our curve as a function of theta. Okay. And here are two examples. So here r equal to 2 sine of theta, and this is our f of theta. So this is what we mean by r equal to f of theta. It's just similar like, when you guys have, for example, y equal to sine of x, for example. So here y is a function of x. Okay. And another notation or to represent a polar curve could be also theta as a function of r, and that the meaning of this notation, theta equal to g of r, is similar to what we guys have here. So next later on we'll see how to sketch the curve of such equation called polar curve. So right, first we'll see, just gonna remove this. So you guys are done for this one? In the first example, the curve is in terms of theta. For the second one, the curve is in terms of r. But as I said, we'll see this notation. And before doing so, I just want to give you how to find the derivative of y with respect to x. So knowing these two formulas that we've seen previously, and we prove it, x equal to r cosine of theta, that's what we used before, and y equal to r sine of theta. But in this case here, r is a constant. You see, r here is not constant like the previous cases. So r in this case is a function of theta. So it means r depends on theta. Okay. In this context, you just want to know how to calculate dy by dx. So since we don't know exactly how y depends on x, so what we do know here is how y depends on r and theta, and also how x depends on r and theta. So since we don't know how to calculate, dy by dx directly, so what we have to do is introduce up and down here, d theta. So you divide up and down by d theta, and the formula becomes the derivative of y with respect to theta over the derivative of x with respect to theta. And this is going to give you the derivative of y respect to x. And you guys can see this is similar to the derivative of y with respect to x that we've seen in a case of parametric equation. It's the same formula. So the only difference here is now x and y depends on theta, not on t, like with the parametric equation. Okay. So next we'll see how to apply it in order to find the slope of the tangent line passing through the point theta equal to pi over 3. So now we want to get, in this example, the slope of the tangent line to the curve C. So the curve C is defined by this equation. Okay. This is the equation of C, and we want to get the slope at pi over 3. So now let's see how to calculate it. All right, so again, we have C defined by r equal to 1 plus cosine of theta. And as I said, we just want to get the slope of the line tangent to this curve C when theta equal to pi over 3. And to calculate the slope M, so it's going to be dy over dx at theta equal to pi over 3. And to calculate dy by dx, as you know, it's going to be dy by d theta over dx by d theta when theta equal to pi over 3. So it means you have to calculate the derivative of y with respect to theta and the derivative of x with respect to theta. But if you guys want to calculate these two derivatives, we first need to know how x and y depends on theta. Okay, so what we do know here is x is equal to r cosine of theta and y is also equal to r sine of theta. And since theta depends on r based on what you guys have here on the top, r is equal to 1 plus cosine theta. So we have to substitute here in both equations. We have to substitute r by its value. And by doing so, you guys have to multiply with cosine. So you put your r inside a bracket, r equal to 1 plus cosine, you multiply with cosine. So we'll get cosine theta plus cosine squared. As you can see, cosine theta times 1 here going to give you the first term, and cosine theta times cosine theta going to give us the second term. And we repeat the same technique here, replacing theta by its value and multiplying with sine. So we'll get here sine theta times 1, going to be sine theta. And here sine theta plus times cosine, we'll get the second term here. So now we're ready to calculate the derivative because we know how x and y depend on theta. And back to our formula here, I'm going to calculate the derivative on the top here, the numerator. So we need to differentiate y by the derivative of the first term here is equal to cosine of theta. But when we want to differentiate the second term, you guys can see here, this is the product of two functions. And to calculate the derivative, you have to use the product rule. And when you use the product rule, you differentiate the first factor. So we'll get sine of theta. So here's the theta is missing. It's supposed to be sine of theta. Yeah. So you differentiate by using product rule, going to be sine theta, derivative of cosine times this second factor. And next step, you keep this function which is equal to cosine and you differentiate sine, you will get cosine here. And we're done with the numerator. So now when we differentiate the denominator, so now you differentiate the denominator here. So this is a denominator is x. You differentiate cosine is going to be minus sine here. So to differentiate cosine square of theta, this is a composite of two functions. You guys have to use the chain rule. And doing so, you get 2 cosine of theta times derivative of cosine, which is equal to negative sine. Next step, we're going to substitute theta by its value in order to get the value of m. And that's exactly what I did here. From this step, I'm just going to substitute theta by pi over 3. And second last step, we're going to calculate this value. If you calculate cosine of pi over 3 is equal to half, you just calculate here sine of pi over 3 going to be root 3 over 2 times root 3 over 2 for the second factor here. And for the last term, cosine of theta is equal to half. So for the denominator, sine of pi over 3 is equal to root 3 over 2. And for the cosine of pi over 3, we'll get 1 over 2. And negative sine of pi over 2 is going to be negative root 3 over 2. And calculating the numerator, so you guys can here we end up with 0. And the denominator is going to be negative root 3. And the slope going to be 0 in this case. Any question?
So ys equal cosine plus cosine square.
Pardon?
Ys equal cosine plus cosine square.
X here?
Yes, yes.
Yeah, I just substitute r by its value. So r is here. You see? Now, if you substitute here r by its value, you multiply by cosine, it's going to be cosine of theta times 1. You will get cosine theta. And cosine theta here times this cosine, going to be cosine square theta. Is it okay? Hello?
Okay, okay, sir.
That's okay. All right.
Oh, what about the sign?
Where? The sign is
The
for
sign.
y. Is for y. There is no sign here for cosine for x.
Yeah, yeah. On the
For y, you calculate sine times r here. When you substitute r by its value, is going to be sine theta times 1, and you will get the first term here. And sine theta times cosine, you will get the second term.
oh, I see.
Is okay?
Yeah.
Yeah, and down here, I just differentiate, okay? I didn't put, on the top here the y. This is the derivative of y. You differentiate this first term here to get this. And when you differentiate this product by using product rule, you get, so you will get these two terms. Any question?
No.
So could you please go over the last step again?
So this step?
Yeah.
Yeah, I just calculate cosine of pi over 3. Okay, so when you calculate it, cosine of pi over 3 is going to be just 1 over 2. And I calculate here sine of pi over 3 is going to be root 3 over 2. So you repeat it here. That's why I have, this is the first sine pi over 3 and the second sine pi over 3. For the last term is cosine of pi over 3 equal to 1 over 2. And the second one here going to be 1 over 2. Okay?
Thank you.
You're welcome. And the values below here are exact same thing. Sine, this sine pi over 3 is negative root 3 over 2. And 2 times cosine of pi over 3 is equal to this bracket times 2 because of this 2 here. And times minus sine of pi over 3 going to be negative root 3 over 2. So the numerator here, when you calculate it, it's going to be just 0 because this product here going to be 3 by 4 is a minus, and you have here 1 by 4 and negative 3 by 4 plus 1 by 4 going to be just, negative 1 by 2, and this 1 by 2 going to be 0. Any question? All right. So now we're ready to see how to sketch the curve of a polar equation. I'm gonna sketch these two curves. All right, first example, we have r equal to 1 plus sine of theta. So we're gonna sketch it. All right, to sketch the curve, we're gonna use first a table of values as you did in XY coordinates. So we wanna pick some values between 0 and 2 pi because here's the question does not mention any range for theta. And just keep in mind, if the question mentioned, a range for theta, you only need to sketch that part of the curve. Okay, the portion on the curve for which theta is in the range. But here's a question that does not mention anything, so that's why we have to take all values of theta between 0 and 2 pi. Okay, and to do so, I just pick some values because guys cannot take all of them. Okay, I just pick some of the values. It's like just when you guys want to sketch the curve, you have to pick just the values, you know, and find the corresponding y value. That's exactly what I'm doing here. I pick some values for theta between 0 and 2 pi. And to simplify my calculations, I'm just going to pick values for which the sign going to return you a fraction, because I don't need to manipulate the square root. Okay. For example, if I take pi by 4, you know, or pi by 3, the sign gonna returns me just a square root, and I added 1. I need to approximate. It's gonna be time consuming, so that's why I don't want to do that. I just pick some values where the calculation gonna be easier. So that's why I pick, you know, pi by 6. And what I decide to do is just, you know, to pick 2, 3 values in each quadrant. Okay, so for example, in the first quadrant, I just pick here 0, pi by 6, pi by 2. In the second one, I choose 5 pi by 6 and pi, only 2. And in the third quadrant, I pick 7 pi by 6 and 3 pi by 2. And in the last quadrant, I just pick here 11 pi by 6 and 2 pi. Okay, just 2 values from each quadrant. And simplify, and so the calculation, that's why I didn't take, you know, as I told you, the square root. Okay, and when theta equal to 0, when you guys substitute here in the equation of r, so we'll get 1 plus sign of 0, and since the sign of 0 equal to 0, so r going to be only 1. And at pi by 6, the sign going to be equal to 1 over 2 plus 1 is going to be 3 by 2. And at pi by 2, sign is 1. So in this case, plus 1 here to get r equal to 2. At 5 pi by 6, so sign again is equal to half, plus 1, you will get 3 by 2. At pi, sign is 0 at pi. And you add 1, so r going to be 1, as you can see here. 7 pi by 6, so sign going to be negative 1 over 2. And plus 1, you will get 1 over 2. At 3 pi over 2, the sign of 3 pi over 2, as you know, is equal to negative 1. So you add 1 here. That's why we got here r equal to 0. And the second last angle is 11 pi by 6. So the sign going to be negative half, plus 1 is going to be half. And for the last value, sign of 2 pi is 0. So plus 1, we get r equal to 1. Okay, and from this table of values, I'm going to sketch the first curve. Okay, and for this kind of question in the quizzes or midterms, I want to see the 2 curves, because the solution is the second curve and it's obtained from the first curve. That's why I want to see, you know, both curves. Okay, to sketch the second curve is going to be something like, you know, similar to XY coordinate. The horizontal axis is going to be for theta, and the vertical one going to be for r, as you can see here. Now I'm going to locate all these points. So we have 10 points here. So when theta equal to 0, r equal to 1, you get the first point going to be here. That's exactly this one, 0, 1. And when theta equal to pi over 6, so your r equal to 1.5. That's exactly what we got here. At pi over 2, so you'll get the maximum value for r going to be 2. The third point. And the fourth one is this point. Again, you get 3 by 2 for theta equal to 5 pi over 6. And theta equal to pi, you get this point going to be, you know, the fifth one going to be at 1. And when theta equal to 7 pi by 6, going to be this point here. R equal to 1 by 2, which is equal to 0.5. And when theta equal to 3 pi over 2, it means r is equal to 0. We'll get this point. For the second last point here, theta equal to 11 pi over 6, and r going to be half, and the last point 2 pi 1, and we join all these points by using this curve. And as it was at the beginning, we just took here values between 0 and 2 pi. Okay, so I'll let you take this graph first, and we'll see the next one, how to sketch it, because it's going to be more complicated than this first graph, because this first one is just similar to the XY coordinate. Yeah. You done? Or you have a question? Pardon?
Question.
Yeah, go ahead.
Question. From 0 to
I didn't get your question. So your mic isn't working properly.
So the R has to be on the
Pardon?
y-axis. The R has to be on the y-axis, and the theta
Yeah.
on the
So
x.
this is the R, and this is a theta for axis for theta.
Yes, sir.
Because the function is defined in terms of theta. So we'll see the graph in polar. So this is not the graph in polar. So we're going to use it to sketch, the graph in polar. That's why I said I want to see this curve too, because this curve is going to help us to get the graph. Yeah.
Sir, for the all time, we have to take the interval from 0 to 2 pi, or it depends from the function?
Now, if the question does not mention the range, so you have to take 0 to 2 pi. Otherwise, you use the interval given by the question.
Okay, sir.
Okay. Now let's see how to sketch the curve in polar. I'm just going to show you some details here before showing the final one. Okay, so in polar, what you guys have to do, okay, how this curve was obtained, that's what I'm going to show you here. So you start by, so for example, you pick your pole. Okay, let's say this is your pole here. It's O. And you draw your horizontal line, as I told you. And by just taking the horizontal line, oops, I'm gonna remove it. Okay. So this is the pole O. And I have my horizontal lines because I have to use it for my angles. That's what I told at the beginning of the class. And I'm going to use the vertical line here to get the right angle first. So you notice here for this line theta equal to 0 because there is no inclination in this case. And for this one, the vertical one, theta equal to pi over 2. This is pi by 2 because we have a right angle. When we start from this horizontal line up to here, the angle is a right angle. And if you start from here up to this side, you guys get here theta equal to pi. And below here is going to be theta equal to 3 pi over 2. Okay, so you guys can see here. So we have 0, so no inclination. If you go from this position up to here, the angle equal to pi over 2. You add pi over, going to be pi. 3 pi over 2, 4 pi over 2, going to be 2 pi. So here you come back here, so we'll get theta equal to 2 pi. Now, so from this, the first graph, you try first to find these, to locate these points, these 10 points. For the first point, theta equal to 0 and y equal to 1. And when theta equal to 0, so it means there is no angle. In this case, you have this line. Okay, and since r equal to 1, it means you have to take 1 unit on this line. Okay, I'm just going to change the color here. You guys can see. Okay, so this is going to be my first point. And it's exactly what we have here. This point is obtained when theta equal to 0. So that's why you don't have any angle between, the line and the horizontal line. And r equal to 1, you take 1 unit from 0, because r means the radius, the position on the curve with respect to 0. That's what we did at the beginning when we was defining, the polar system. I told you any point is located with respect to the reference point, which is, r, which is the pole. And for the second point, when theta equal to pi over 6, so I'm going to draw the line pi over 6. Pi over 6, guys can see it here is this line, approximately. This is a line, theta equal to pi over 6. It means this angle is equal to pi over. That's the meaning of this writing. Okay. Now, when theta equal to pi over 6, r equal to 1.5, it means I have to take on this line 1.5 units from 0. So starting from 0, I'm going to take, let's say this is 1, and we have 2 here, 1.5 going to be here. Going to be my second point is this one. And for the third point here, when theta equal to pi over 2, but pi over 2, as I told you, is this line, is this angle is equal to pi over 2. Now, if theta equal to pi over 2, maximum value of r is attained equal to 2. So I have to take 2 units from 0. So let's say this is 1 unit, and the second one going to be somewhere here, for example, 2 units. So it means I'm going from this point up to here. Okay, and what I did so far is just this point, the first one, the second point is right here, the third one. And for the fourth one, it's theta equal to 5 pi over 6. It's going to be here. And on 5 pi over 6, r equal to 1.5, like what we got here. So we have here 1, for example, and we have 2, 1.5 going to be here. Okay, and at pi, so at pi, you guys can see here at pi, we have 1. So pi is here, r is positive, you stay here. If it was -1 pi, you will get this. I told you locate the angle. If r is positive, you stay there. If r is negative, you take the symmetry. So we will locate the angle is theta equal to pi. R is positive, you're gonna stay here. We have taken 1 unit. So it's gonna be 1 unit from 0. I told you, anytime you guys locate a point, it's gonna be with respect to the pole 0, O. And 7 pi over 6 is gonna be the continuation of this line. Okay, this is 7 pi over 6. And for 7 pi over 6, you guys can see we have 0.5. So that's why we'll get something like that, 0.5 unit from 0. And at theta equal to 3 pi by 2, r is 0. And when r is 0, it means the point coincide with the pole, because at the pole, r is 0. I told you, r represents, the distance between the point P and the pole. But if that distance is 0, it means the point and the pole coincide. And for the other values, going to be similar. Now, how to join this point? I'll not do the remaining two values because the last one going to be just at 2 pi, we return to 1. Going to be this point. So how to join these values? We have different ways, but the correct one is you cannot go from this direction. Going to be the negative direction. The positive direction is this way. That's why we have to go that way. And starting here, how to join these 2 points, the radius is increasing based on what the graph says. You guys going from the first point to the third one, the graph is increasing. It means here the radius is increasing. And the radius means the distance from your position to 0. That's the radius. And you see when you join these 2 points, you get, for example, this. And what we call R is not the curve. The curve R is this distance, is the radius. All this. You guys can see when you're moving from the first point to this one, the value of R is increasing because at the beginning, the value of R is 1. This is R at the beginning is equal to 1. And at this point here, R is equal to 2. At this point, R equal to 1.8, for example. So here's going to be 1.6. Okay, you see when you moving along this curve by taking the positive direction, so the value of R is increasing up to 2. After the value of R, this is also R, is decreasing. Okay, and you will get exactly joining these 2 points up to here, 0. Okay, I didn't represent these to the last point here. If you do it, you will get this one. And if you guys, look at the curve, it looks like, a heart. That's why we call it a cardioid. Any question? Any question?
No, sir.
Yeah. I'm just gonna remove this, and you guys can see exactly what look like the. So you good? All right, so let's move on to the second and last example. So now we have r equal to cosine of 2 theta as the equation of the polar curve, and we want to sketch it too. And as I mentioned here, you guys can see the range of theta is not given. That's why I will take 0 to pi as a range. All right, again here. So this is our curve, r equal to cosine of 2 theta. And as I mentioned before, theta is in the range 0 to 2 pi. Again, I'm going to pick just, some values where the calculation going to be easier. And just take like, 2 to 3 values or 2 values from each quadrant. So for example, in the first quadrant, I'm going to pick 0, pi by 4, pi by 2 here. In the second quadrant, you guys will get pi by 2, 3, pi by 4. In the third one, we'll get pi, 5, pi by 4. And in the last quadrant, you will get these values. Okay. And as I said, the reason why I took, pi by 4 instead of pi by 6, like the first example, is just to simplify my calculation here because of the question 2. If I take pi by 4, so it's going to calculation going to be easy. I'll not need any square root in this case. That's the only reason. Now, if you want to take more values to get more precise, or more accurate curve, so you can take more values. Okay, if you have time to do so, you can do it taking, pi by 3, pi by 6, 2 pi by 3, and so on. Okay. So here, when theta equal to 0, you substitute in the equation here, we'll get cosine of 0, going to be just 1. At pi by 4, we will get cosine of 2 pi over 4. When you simplify by 2, it becomes cosine of pi by 2. And we know cosine of pi by 2 is 0. And at pi by 2, you substitute here again, it becomes cosine of pi, which is equal to -1. 3 pi by 4 again, after simplification, you will get cosine of 3 pi by 2, going to be 0. At pi, you will get cosine of 2 pi, is going to be 1. So when you substitute theta by 5 pi over 4, so we'll get cosine of 5 pi over 2, which is again 0. And at 3 pi over 2, it becomes cosine of 3 pi after, replacing theta by 3 pi over 2. The 2 cancel out and you will get cosine 3 pi. And we know is equal to -1. And at 7 pi by 4, you simplify by 2, it becomes cosine of 7 pi by 2, which is equal to 0. And at 2 pi, you will get here cosine of 4 pi, which is equal to 1. And now we can sketch, represent the first curve. So we'll get exactly this. So this is our first value when theta equal to 0. So r equal to 1, you will get the first point, 0, 1. At pi by 4, r equal to 0, so we'll get this point. So the curve, crosses the horizontal axis because r equal to 0. And when at pi by 2, this third point is exactly what we got here. And the fourth point is here, 3 pi by 4, 0. And the fifth one going to be here at pi, you get 1. At 5 pi by 4 becomes 0 is this point. At 3 pi by 2, we have -1. At 7 pi by 4, 0 again. And at 2 pi, we'll get 1. So you guys can see here, r equal to 0 4 times. You can see it from the table or from the graph. As soon as you know the curve crosses the horizontal line axis, it means R is 0. And as I told you, based on what we did in the first graph, anytime R equal to 0, it means the curve crosses the pole, because R represent the position on the curve and the pole. If R is 0, it means the point and the pole coincide. So it means here the curve will visit the pole 4 times, because R equal to 0 4 times. Okay. Now let's see how to sketch. All right, so as I said before, to locate the point, so the first point is 0 1, and theta equal to 0 is here. So when theta equal to 0, R equal to 1, so it means theta equal to 0 is this line. You have to take 1 unit from 0. So this is 0, the pole. So 1 unit gonna be here. This distance equal to 1. And at pi by 4 is this line, because it's half of the right angle. So this is pi by 4 is this angle, in fact. But at pi by 4, R is 0. So this is the first point, and this is the second point. And the next point is at pi by 2, but pi by 2 is here. But at pi by 2, R is negative, it's -1. And I told you, when R is negative at pi by 2, it means you cannot stay in the same quadrant. If it was 1, you're gonna stay here. But we see here at pi by 2, R equal to -1. It means instead of this point, we have to take the symmetry, gonna be this point, as you can see here. This is -1 pi by 2. As I told you, first locate pi by 2, which is here, and you take -1 to send it here. Okay? And at 3 pi by 4 again is going to be 0. And at pi, so pi is here. At pi, R is positive, it means we're going to stay here. So this is a point 1 pi, this point here. And so on. Now, when you join this point, you're going to start here. As I said, this is the first point. So you go up to here, second point. And the third point going to be at pi by 2, go here. And come back to 0. And from here, so you have to go up to here. So this point is at 3 pi by 2, because you guys can see at 3 pi by 2, you get -1. So 3 pi by 2 is here. Since you have -1, you have to go to the other side. If it was 1, so we'll get this point. Okay, so the curve starts here, and we'll get exactly this. Go up. Okay, so we'll get this part here. Go up now, down, and we'll get this. And this looks like a flower with 4 leaves. That's why we call it, 4 rose leaves. Any question? So I'll let you write down, this one.
Sir, are we done for today?
Pardon?
Are we done for today?
Yeah, I'm just waiting if you have a question. Otherwise, I'm going to take the attendance before letting go.
Sorry, I have a question, but just off the topic.
Pardon?
The term test.
Yeah.
So we have thumb test in this way in Friday. Right?
Let me see.
It's
The
Friday.
test. Oh, the first test. What is it again? It's already in the course outline. Let me double check. Yeah.
So the test coverage is said is 4.4. So it's week 1 and week 2. We cover week 1 and week 2. But in the example, the sample that you showed us, it includes the week 3. So
which example?
The sample midterm that you posted for us.
Yeah, because this is a different situation, you know.
So we only need to solve the question in the week 1 and week 2 in sample midterm.
Yeah.
Oh, okay.
Yeah.
Okay, thank you.
So usually, you know, because this time we have three tests. So usually we have just, you know, 2, and the first test will cover up to integral. But this time, because of the COVID-19, so that's why we have 3 tests and change the whole thing. So that's why it will not be similar to the previous one. It's going to be a little bit similar, but you have just to solve questions relating to related to these sections. Okay, 4.4 is L'Hopital's role. 1.6 for the inverse trig functions, and that's it. And 3.5.
Okay, thank you.
Okay.
Sir, do we need to come on the Zoom meeting?
For what?
For test?
No. The test gonna be with crowd.
Like, so we don't have to come on the Zoom meeting for your webcam.
No, so you check here before I tell you again, because so you see it here.
Yes, sir, but the above, it is like for all lectures, the above one.
You have here the details for the test. You have to copy it by using Proudmark. Okay.
Yes, sir. But could you please scroll up? Yes, sir. Sir, here it is mentioned that for all lectures and test and exam, you have to join the Zoom meeting. That's why.
Okay, and if you have won the position. Okay, so I'm gonna let you know tomorrow, because I have to talk to my other colleague to know exactly how to do it, because last term I didn't do the test online, so I don't exactly how it's gonna work. But I'll let you know tomorrow. Okay.
Okay, sir.
Okay. Thank you.
So could you please go back? Could you zoom out, please?
Yeah. Yeah, we did it in by using numbers. On that question, we didn't specify the value of x, but the process is going to be the same. By using just a triangle, you can do it. Yeah. You know what? I'll tomorrow I'm gonna post, the solutions. Okay, and you guys can use it in your review. Are you done with this? Okay, I'm gonna stop sharing my screen. I'm just take the attendance, please.